So I'm going to ask you to graph the coordinate 3, -7. So take a moment, put your best shot about where you think 3, -7 is. So where is it? Where is it? Where is it? Where is it? Oh, great job, you guys. Man, y'all are doing this so fast. I put a little reminder for you to remind you of where the positives and negatives are on one side of it if you need it. But it sure doesn't look like most of us need it. So we're going over to the right 3 and then down 7 so that we can graph the coordinate 3, 7. And let's call that coordinate A. I haven't given it a name yet. Let's call it coordinate A. So I'm going to ask you to flip or mirror or the big kid word reflect, but you've got to actually have somewhere to reflect it over, right? We need a line to reflect it over. And today we're going to practice 2 types of reflections. The first one is going to be reflecting it across the x-axis. So highlight for me on your dry erase board. Just kind of take your marker and either make a mark across the horizontal axis or the vertical axis, whichever one you think is X. So which line am I getting ready to reflect this over? If you get it wrong, nobody cares. That's why it's dry erase, right? If we goof, nobody cares. Ah, beautiful job, guys. So the x-axis is this one right here. So we're going to reflect it across the x, which again means that we're starting off with this guy over here. Once we get done, we're going to pick him up and we're going to flip him over to the other side of that axis. So how do you decide exactly how far he needs to go? So because my line of reflection is the x-axis, I'm going to use that to count. So coordinate A right now is 1, 2, 3, 4, 5, 6, and 7 units below the x-axis, right? So that means that if I pick it up and I flip it over, it's now going to be 1, 2, 3, 4, 5, 6, and 7 units above. So if my pre-image was 7 units below, the image is going to be 7 units above. So that's a super important concept to make sure that you've got. First of all, the A and its reflection, the A prime, they're right directly across from each other. And they're the same distance from that line of reflection. So coordinate A, again, was 3, -7. Write down the ordered pair for A prime for me, please. What do you think A prime's coordinate is if I were going to give an address for A prime? We know that A is 3, -7. What is A prime? What is the ordered pair that goes along with it? What you got?
3 +7.
3 +7. Do you agree? You should, because he's right. What do you notice about the coordinates from the pre-image to the image? What does my blue ordered pair and my black ordered pair have in common? What's similar about them? What do you got, Charles?
The first number is the same.
First number is the same. And guess what? Now, what is that first number? Is that first number my x-axis or is it my y-axis? My x-coordinate or my y-coordinate? Which one is the first one?
I think it's the y.
So it goes in alphabetical order. So, yep. So you're right. So x. So that is not a coincidence, friends. Every single time that you reflect a coordinate over the x-axis, your x-coordinate, just like Charles just told me correctly, is going to stay the same. So you're going to you don't have to necessarily write this down. Because if you're a visual person like me, gives you something to refer to visually. So your x-coordinate stays the same if you reflect it across the x. Now, what do you notice about the y-coordinate? What's the same about the y-coordinate, my blue versus my black? What's the same, Jack?
It's the same number, just positive and negative.
Agreed. So instead of a negative, it turns to a positive. So The rule for when you're flipping over the x-axis is your x is going to stay the same, but then you're going to flip the sign of your y. And that works every single time, friends. And if you think about it, it makes sense. The x-coordinate probably has to stay the same because it didn't move left to right. It just shifted up or down. So your x-coordinate is going to stay the same. Is there anybody not okay if I go ahead and ditch this and give you another one? Are we okay? Okay, no, nobody's telling me no. Okay, so here's another, I want to give you another ordered pair. So we're going to start off by graphing. We're going to call this one coordinate B. And let's graph -2, +3. So where is the ordered pair -2, 3 going to go? Where's it going to go? Where's it going to go? -2, +3. Oh, you guys are just too good. All right, we got it. -2, +3. There is coordinate B. So now, instead of flipping it across the x-axis, I'm going to flip it across, or I should say reflect. I'm sorry. I'm going to use my proper math vocab. Instead of reflecting it across the x-axis like I did last time, this time let's make our line of reflection the y-axis. So you guys take just a second and pretty please, why is this not, there we go. Show me on your board where you think B prime is going to be. If I take B and I reflect it across the y-axis this time, take your best educated guess about where you think that B prime is going to land. So if I take it and reflect it across the y-axis, where is it going to go? What is your best guess? I see you, Jack. I'm just looking at everybody's boards right now because I don't want this. We're brand new. I want to see an answer from everybody. It's okay if we're not correct because right now you can't screw up an educated guess. All right, so my y-axis, everybody's got a guess. I love it. All right, so if my coordinate is 2, so look at your line of reflection and see how 2, 3 is, let me make that a little bit easier to see here, how it's 1, 2 units to the left. That means if you reflect it over the y-axis, it's going to be 1, 2 units to the right. If you goofed, no big deal. Okay, here's what I saw several people do, which I totally understand. I saw a lot of people, remember if it's red, it's what? Not quite right. Okay, so I saw a lot of people doing this. Now, if I did that, what did I just reflect it over instead of the y-axis? It's a really common boo-boo. What did I do wrong, Journey? Yeah, if you did what I just did in red, you just goofed and you reflected it across the wrong axis. So you know how to do a reflection, so that's cool. Okay, we just made the mistake of going over the wrong axis. So no big deal, okay? So I'm going to go back and do it in the right place now. So instead of -2, 3, B prime is going to be 2, +3. So what do we notice this time when we reflect it across the y? What's the same? What's the same, mathematicians? I know it's Friday. We're almost done. Edward, what you got? The y is the same. So this time, instead of keeping the x coordinate the same, we're going to keep the y coordinate the same. And then which coordinate did I flip? This time, I flipped the x instead. Exactly. So we flipped our x coordinate. All right, so we're going to play a little Kahoot just to practice this idea of, I'm sorry, not Kahoot, I meant Blue-Kit, sorry. Okay, I like Blue-Kit way better than Kahoot. So now we're going to practice reflecting an entire shape. And the best way for you guys to do this, guys, that's better. All right, So first thing I need you to do, pretty please, and I'm just going to do like one of these with you guys because the best way for you to do this is just to practice it more hands-on. But I want to do one is with the group. So first of all, we need a shape to graph. So please graph triangle. We're going to call this triangle ABC. And A's coordinate will be here. B's coordinate will be here. And C's coordinate will be here. So take just a minute to graph that triangle, please, and thank you. Graph triangle ABC. So graph it making 3 dots, 3 coordinates that'll make up the vertices of that shape. Remember, vertices is the big kid word for corner. It's a vertex. It's the corners of the triangle. It doesn't need to be perfect. Mine's certainly not getting ready to be. I'm a terrible, terrible artist. I'm very envious of those of you guys that looks right, sir. So a lot of you guys are already getting there. So I'm going to go ahead and graph my version so you can check yourself. So A should be there at -2, 3. B should be here at 0, -5. And C should be right here. So what I personally think would be a good idea, and I should have already told you guys to do this, my bad. Look and see in the little pencil boxes on your table, there should be more dry erase markers. See if there's another color. Helpful in this case if you do your image and your pre-image in a different color. If you don't have a different color, awesome. Okay, so friends, we are getting ready to reflect this, and we're going to reflect it across the y-axis, but it's going to look a little goofy to you, okay? Because the shape is like sitting on the reflection line, okay? So what we're getting ready to do, quite frankly, a lot of you guys are you're gonna think it looks really messy. You're not really gonna like the looks of it, but it is mathematically correct, okay? So I'm gonna zoom in. I'm gonna erase this stuff, get this out of the way for a minute so that you can see a little bit better. So I got a little bit more space. So I'm going to start by reflecting coordinate A. And so I'm going to zoom in. So my reflection line is here at the axis. And coordinate A is 1, 2 units to the left of that reflection line. So that means that A prime, if we take A and we flip it over here, instead of being 2 units to the left, it is now going to be 2 units to the right. Exactly. So your A prime is going to be on that side of your line. So your original A, your pre-image, was 2 units to the left. So A prime is going to have to be 2 units to the right. And I know for a lot of us that looks visually, we don't like it, that it's kind of overlapping like that. I get that's a little bit disturbing to some of us. That it's not wrong though. I know we might not like the looks of it, but it is correct. So we reflected it over to the other side of that line. What am I going to do with coordinate B?
Same.
If I pick it and I flip it over, what's going to happen with coordinate B if I'm reflecting it across the y-axis? Yeah, it's just going to stay put, friends, because it's sitting on the line of reflection. And personally, I wouldn't do this B prime because it's not moving anywhere. So just leave it. Okay, that's just going to be plain old, like we haven't moved it anywhere. So that coordinate is actually going to stay put. If it's sitting on the reflection line, it doesn't move. And then coordinate C. So coordinate C is 1. I'm going to zoom in here so it's a little bit easier to see. So coordinate C is 1 unit to the right. So if you pick it up and you flip it over, it's now going to be 1 unit to the left. Exactly. So man, we sure don't like the looks of that, do we? If we connect the coordinates, it looks messy. Because it is, and I certainly can't draw either, so I'm not helping matters any. Okay? It looks weird because it's like reflected on top of itself, but it is technically correct. Okay? So I'm going to stop here.